English learners. Welcome back to another lesson with us here at English Pod. My name is Marco.
And I'm Erica.
And today we're going to be talking about physics.
That's right. An advanced lesson for all you physics lovers out there. And even for those of you who maybe don't love physics so much, there's still some great language here.
Right. We're going to be talking about the Big Bang Theory, a very popular theory of how the universe or the world and how we came upon being created.
That's right. So we've got some physics language, but we've also got some really tough words that I bet many of our users have never seen before, which we're going to look at those in this lesson.
All right. So why don't we get started with this great and interesting lesson, and let's listen to the dialogue for the first time.
What's up? You don't look too good.
Yeah, my head hurts, that's all. I've been in physics class all day. It's killer.
I liked physics. It's all math, really. Arcs, curves, velocity. Cool stuff.
Yeah. But today's lesson was all about the creation of the universe.
A physics class about the creation of the universe? That's some pretty unscientific language there. It sounds more religious to me.
It's all religion. Take the theory of the Big Bang. How is it possible that all of the stuff in the universe comes from an explosion? That's no better than Atlas carrying the globe on his back, or African myths about turtles and stuff.
Turtles? Whatever. Look, all that's required for the creation of matter is an imbalance of particles and antiparticles. At least, that's what the math says.
Math schmath. What's the evidence?
There is evidence. You know Edwin Hubble, the guy who in the early 20th century was the first scientist to measure the drift of matter in the universe, thus advancing notions of an expanding universe. What would it be expanding from? Well, the Big Bang, duh.
Anyway, it's just a theory. Why do people go around touting theories? Where's the rigor in that?
Dude, don't equivocate. A theory only becomes a theory after withstanding rigorous testing. You slept through class, didn't you?
You're making my head hurt again. Quit with the question.
Well, it sure does sound like a difficult class, doesn't it?
It's a very interesting topic and very controversial, so there are many opinions on it. But before we get into that, why don't we take a look at some of those physics-related words that we listen to in Language Takeaway.
Language takeaway.
We've got 4 words we've heard in the dialogue that are all related to physics. So let's start with the first one, which is matter.
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 Okay, so you probably know this word from What's the Matter? What's
Right.
wrong?
Yep.
In this case, we're talking about matter, so anything that occupies space, that has a mass, or that is related to energy. So, matter.
So all things in the world are made up of matter, right?
Exactly.
Okay.
Now let's move on to another one.
Particles.
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 Now, particles are a little bit more... Now, particles are a little bit easier. They're just very small pieces of a whole.
An apple is made up of apple particles.
Something like that. You can, if you want to understand it easily, apple has many small particles that make up the apple.
So, let's paint a picture here. Imagine we've got a beach, and all the pieces of sand are particles of the beach.
Exactly. Very good. So those are particles.
Now, the next one is a little bit difficult for me. I don't understand this. Antiparticles.
All right. So antiparticles.
Antiparticles.
Now, this prefix, anti, it means something that is against, right?
Right. And I've seen this one in anti-clockwise.
All right. So antiparticles are those that are against particles. So basically, if you have a particle that has a positive charge and another one comes in with a negative charge in the same weight and the same type of particle, if they get together, they cancel each other out and they both die.
Oh.
So that's an antiparticle.
All right. Well, you heard it first here at English Pod.
So antiparticles are not a good thing to have around.
Now, we also heard them talk about the drift of matter.
Right. Drift of matter.
Drift of matter.
Also sometimes called drift of dark matter.
Okay, well, I know the verb to drift, right? To sort of float away on the sea.
Right. If you have a little ship, you leave it on the beach, it'll drift away. It'll go slowly away.
Yeah. But what about drift of matter?
So basically, the drift of matter is this residue, the remains of the Big Bang, of the explosion.
Okay.
So matter and radiation keeps on drifting through the universe.
So it's moving slowly through the universe.
Moving slowly. So this big explosion, and just consider it to be like this ripple, and it's expanding and expanding. That's the drift of matter.
All right. Well, I learned something else today.
Some very specific words related to physics, but it's very interesting. Once you get into reading about these things, it will help you to understand it better.
That's right. But we've also got some non-physics related language that we want to look at now in Language Takeaway Part 2.
The drift of matter and how it's drifting through the universe. And then he said, thus advancing the notions of an expanding universe.
So I want to look at the phrase, thus advancing notions.
Thus advancing notions.
Okay, let's start with the first word here, thus.
Okay, so this is a good connector
Or conjunction.
or conjunction. And basically it means
Therefore.
therefore or in consequence,
Yeah.
right?
So thus advancing notions. Now, notions are ideas.
Right.
And so when you advance notions or advance ideas, you help them make progress. You help them go forward and become known.
Okay, so in order to understand this in the context, they are saying that the drift of matter thus advances notions of an expanding universe. So it is making progress to people believing that the universe is getting bigger.
Okay, so interesting phrase. Now, I really like this word thus, and a lot of people are afraid to use it. So why don't we hear a few examples of how it's used in context?
Example 1. So you can see that we've studied the fossil record, and thus we can conclude that evolution is a fact. Example 2.
He broke severe company policies, thus we had to fire him.
Example 3. I did not receive the documents on time, thus I was unable to send them to you.
All right, good examples of thus, and I guess now we can use it a little bit better.
That's right. Now let's move on to our next word. So they were talking about people who go around touting theories.
Tout.
To tout.
Okay, so what does this mean, tout?
Well, basically, when you tout something, you talk about it in a positive way, so as to almost like sell that thing.
Okay,
So, for example, we can say, the company is touting the many benefits of its product.
okay, very good. So to talk positively about something.
Yeah, with the idea of trying to sell that thing or make people buy into it or believe it.
All right, very good. What about our next word?
Well, we heard two related words in the dialogue. They were talking about where's the rigor in these theories and rigorous testing.
Okay, so what's the difference between rigor and rigorous?
Rigor is the state of being very clear and careful and exact.
Okay,
And rigorous is just the adjective. Clear, careful, attention to detail, and exact.
okay, very good. So rigorous training.
I'm going over my notes in rigorous detail.
Okay, very good. And now we have one more word today in language takeaway, and that is equivocate.
So we heard, dude, don't equivocate.
Don't equivocate.
Don't equivocate.
All right, so what does he mean by this?
Well, when you equivocate, you use big words to try and mislead somebody.
Okay, so using big words to confuse or to mislead.
Yep. So, for example, we could say the job candidate. We could say, when asked about his experience, the job candidate equivocated.
Okay.
Or even the presidential nominee did not equivocate when he explained his tax policy.
All right, so some good examples, good phrases, a lot of interesting stuff, and a little bit more educational podcast today.
That's right. So let's continue with our education by listening to the dialogue one last time.
What's up? You don't look too good.
Yeah, my head hurts, that's all. I've been in physics class all day. It's killer.
I liked physics. It's all math, really. Arcs, curves, velocity. Cool stuff.
Yeah. But today's lesson was all about the creation of the universe.
A physics class about the creation of the universe? That's some pretty unscientific language there. It sounds more religious to me.
It's all religion. Take the theory of the Big Bang. How is it possible that all of the stuff in the universe comes from an explosion? That's no better than Atlas carrying the globe on his back or African myths about turtles and stuff.
Turtles? Whatever. Look, all that's required for the creation of matter is an imbalance of particles and antiparticles. At least that's what the math says.
Math schmath. What's the evidence?
There is evidence. You know Edwin Hubble, the guy who in the early 20th century was the first scientist to measure the drift of matter in the universe, thus advancing notions of an expanding universe. What would it be expanding from? Well, the Big Bang, duh.
Anyway, it's just a theory. Why do people go around touting theories? Where's the rigor in that?
Dude, don't equivocate. A theory only becomes a theory after withstanding rigorous testing. You slept through class, didn't you?
You're making my head hurt again. Quit with the question.
All right, so the Big Bang Theory, very controversial. In some schools in the United States, they have prohibited the teachers from teaching it.
I know, seems quite interesting to me. But it is actually very controversial, and people can get really, really upset about this in America.
So it is an interesting topic. Take it from the point of view of just something else, maybe just to learn a little bit more about this topic, such as physics, right?
Right. But there's something that is uncontroversial that I did want to talk about now that we heard in the dialogue. There's a lot of really interesting sort of slang words here in the dialogue, isn't there?
Yeah, we heard in the first part of the dialogue when he said, "I've been in physics class all day. Killer."
Killer.
So what does he mean by killer?
Oh, he's just basically saying it's really hard. You know, it's like it's so difficult that it's murderous.
It was intense.
Yep. But this word we can use positively as well, can't we?
Yeah, I guess you could say that was a killer party.
Yeah, killer moves on the dance floor.
Okay.
Another interesting thing is that he said math schmath.
Now, schmath isn't really a word.
No, but this is a really common structure we use in English when we want to sort of take away from the importance of an idea.
Okay, so you're saying it's not important, I don't care about it, or it's not worth it.
Yeah, so for example, I'm on a diet.
Right, and I would say diet, schmiet.
Yeah.
So basically, the structure is just added sh and then just kind of make it rhyme.
Yeah.
Schmiet, or like
work schmirk.
yeah, work, schmirk, or
Yeah.
something like that.
Yeah.
So you're just making fun of it and you're taking away importance.
Yeah, that's a pretty neat phrase. And one more. We heard them say duh.
Duh.
So when we say this, we're just saying like, you should know this, stupid.
Yeah, this is obvious.
Yep.
It's kind of making fun of the person, or
Yeah.
just saying it's so obvious, how can you not know it?
Yeah.
And it always goes either at the beginning or at the end of a sentence.
Yeah, so duh, Marco, we're recording a podcast.
Right. Very good. So some great words and phrases in this dialogue, and a little bit of slang as well, so you can use it maybe with your friends.
That's right.
Physics, understanding the natural world. Physics is the science that explains how everything in the universe works. It is all around us, shaping our daily lives in ways we may not always notice. From the way we move to the way light enters our eyes, physics is present in every action, movement, and natural event. It is one of the oldest sciences, studied by great minds throughout history to uncover the hidden rules of nature. Whether we are looking at the motion of planets, the speed of a falling object, or the invisible forces that hold atoms together, physics provides answers to some of the biggest questions about the universe. The study of physics began thousands of years ago, when people started observing the natural world. They noticed that objects fell to the ground. The sun rose and set in a predictable way, and fire produced heat. Early scientists tried to understand these patterns, leading to the discovery of fundamental laws that explain motion, energy, and forces. Over time, physics developed into a major scientific field that helps us understand not only the Earth, but also the vast universe beyond.